Lab 1, charge tapes. So our goal for this lab is to find the approximate amount of excess charge on a single piece of Scotch tape that we charged. How we did this, or how we charged the tape, was that we had a piece of base tape taped to the surface of a table, and then we put a piece of upper tape on top of that base tape, and we ripped it off. And we know that objects can gain or lose excess charge through friction and separation. So this explains why we did this. The two big assumptions that we make is that we're treating the tape as a point object with all charge and mass at the center of the tape in both our simulation and calculations. We also assume that both tapes have an equal amount of excess charge since they were charged by the same process on the same surface. We use Newton's law and Coulomb's law to help us in our equations and calculations. So we know from the lab notes that if you rub a clear plastic object like a pen through your hair, it ends up having a net negative charge. And so we put our piece of charged tape next to this negatively charged pen, and they attracted. Therefore, we know that the tape has a net positive charge. And so our setup looks something like this in the diagram. We had our top piece of tape, which was charged, and then we had our bottom piece of tape, which was also charged. And so we assume that they're going to repel each other. And so we took an iPhone camera and we captured this interaction like this. So this distance right here, we assume is 0.5 centimeters. And so here is our calculations. We did um, a couple different calculations. So the first one is we drew our free body diagram up here in the top left. And we basically stated that since the system is in equilibrium, the top tape or the bottom tape is neither accelerating upward or downward. We said that the force due to gravity on the top tape is equal to the force due to the electric field of the bottom tape on the top tape. And here's our calculations for that down here. And we got that our excess charge on that piece of Scotch tape was 2.33 times 10 to the negative 9 coulombs. Then we went over here and we found the number of deficit electrons. So we just converted the coulombs to electrons using this conversion factor right here. And so then we used the atomic surface area and the tape surface area and put them into ratio with each other to find the total amount of surface atoms on the piece of tape. Then we wanted to see what percentage of atoms were lost in this transfer. And so we did a ratio of the number of atoms lost divided by the number of surface atoms times 100 to get this really small percentage. So we know that comparatively, there is a very small amount of electrons being lost in this transfer compared to the whole tape. And so here's my code. We defined all of our variables that we needed for our calculations up here. We defined all of our calculations from this slide. We just put it in the code and we printed the numbers that we're going to get over here. So we have our excess charge, the surface atoms, the atoms that we lose, the percentage, and then we calculate our forces down here. And so this will help us in the next part of our code, where this is basically where we model the spheres and the vectors. So here's my code for modeling the spheres. Here's my code for modeling the vectors. And so down here, we see that a lot of the calculations were congruent with what I got in this slide. They were maybe rounded a little differently, but the computer got the same numbers that I did for the most part. And then, so this red sphere right here is my top piece of tape. This blue sphere is my bottom tape. So we see that these cyan vectors are the electric force vectors repelling each other because they're both negatively charged. And then we also see that this gravity vector pointing downward on that top piece of tape in the orange is equal in magnitude but opposite in direction to this cyan vector right here. So our two lab questions are, what if the electrons had a positive charge and protons had a negative charge? What observations would be changed? Well, we know that since like charges repel each other, nothing in our experiment or calculations would change. we might just call the tape something different. Like we would say it has a negative excess charge instead of a positive excess charge. And so why is it important to handle the charged tapes as little as possible? Well, we know that when we touch these tapes, our hands are very good conductors and they may take some of the electrons or the net excess charge away from that piece of tape and onto our hand, making the tape an overall net equal charge. Thank you.